Welcome to EDU World Space.
All right, so we've got this alpha particle. It's coming along in some direction. It hits a oxygen nucleus, which is at rest, and then the alpha particle goes off at 64 degrees compared to the original trajectory. The oxygen nucleus goes off at 51 degrees on the opposite side. So I've drawn this to help us keep track of where things are. We know the speed of the oxygen nucleus as it comes off. It's 1.2 times 10 to the fifth. And we know the masses in terms of atomic units. The alpha particle has a mass of 4, and the oxygen nucleus has a mass of 16. And so we need to find A, the new velocity of the alpha particle, and B, the original velocity. Well, to find the new velocity, we can just look at the perpendicular components of the momentums of these two and keep in mind that the original perpendicular momentum is 0. So I drew the original velocity in the x direction, so we're looking at the y components of these two, and those have to equal 0. In other words, the y component of the alpha particle's new velocity has to equal and be opposite to the y component of the oxygen nucleus. So we can write this out like this: mass of the alpha particle times the new velocity of the alpha particle times the sine of this angle, 64 degrees, which I'll call theta 1. And this one I'll call theta 2. So this has to equal and be in the opposite direction to the mass of the oxygen molecule or nucleus times the velocity of the oxygen times the sine of its angle, which I said is theta 2, that's 51 degrees. So if we solve this for VA, we get mass of oxygen times velocity of oxygen times sine of theta 2 all over mass of alpha particle times the sine of theta 1. If you plug that in, if you plug in all your numbers for that, you should get a value of 4.2 times 10 to the fifth meters per second. So it's traveling at 4.2 times 10 to the fifth meters per second at an angle of 64 degrees. Now part B asks us to find the original velocity. And for that, we can look at the x components, or the parallel components. And the original velocity, we'll call VAI for initial, has to equal the combined parallel components, the combined x components of these two velocities. So we have the mass of the alpha particle times VA initial is going to equal mass of alpha particle times VA, so that's this right here, times the cosine of theta 1, plus mass of the oxygen nucleus times its speed times the cosine of its angle, theta 2. And so now all we have to do is divide both sides by the mass of the alpha particle, and we have a relation for the initial velocity, which if you plug these numbers in, you should get 4.9 times 10 to the fifth meters per second.